So I am back to re-record because the first try my mic somehow got muted. So I'm just redoing the questions that were done without my mic on. And the other questions that I already answered with my mic on are in the first recording. So in this recording, we're going to do 3 questions over again that we're missing from the last video. So this is the weekly recording, but it's take 2 for some of the questions that I already did. So here we have a question from the Guided Learning Assignment GLA-02. And we have to be very careful to follow the directions on this one to get it marked correctly. So notice that it says to first plot the point on the graph. So the given point here is at the x-coordinate -4 and the y-coordinate 6. So I'm going to start by getting my dot tool down here and plotting that point at -4 for the x value on the horizontal axis. And then I'm going to go up to +6 on the vertical. So I've already done step 1. Now I'm going to do step 2. Use the slope to find 2 other points, one at x equals -5 and one at x equals -3. So we were told up here that the line has a slope of 0, which means that there is no rise. So we are going to stay on this horizontal position for all values of x. So I'm just going to put another point at x equals -5 at that same height and at x equals -3. Okay, so now step 3, graph the line. So now I'm going to take my line tool and just click on 2 of those points to connect my line. And then finally, write the ordered pairs for each of your points. So notice that the y value stays the same for all 3 of these points. So for x equals -5, notice the y value is 6, just like it was for this point and just like it is for the third point. So we just need to put in +6 for all the y coordinates and press submit. And I did get my green check mark and full credit. Yay. Now the next question is graphing these 2 lines, 2 given lines. We've given 2 equations, and they are kind of in y equals mx plus b form. When I say kind of, it's because the first line here just has the m, the slope, and the x, but notice there's no number added or subtracted to the end, so there's no y-intercept. At least it appears that way. But what we can do is look at it like it's a +0. So then your y-intercept would be 0. So we're going to start at the y-coordinate of 0, and then we're going to use this negative slope to move to another point for our line. So let me get my graphing tool, and I'm going to start at y equals 0, and then I'm going to go down 4, since it's a negative slope, 1, 2, 3, 4, a rise of -4, so it's actually not a rise, the opposite of a rise, and then a run of +5. 1, 2, 3, 4, 5, and notice that because it's a negative slope, the line when you read it from left to right does go downward. So that looks pretty good. Now we're going to graph this second equation, and it has a y-intercept of -5. So I'm going to get my graphing utility and go to -5 on my y-axis. And then I'm going to use my positive slope of +5 over 4. So I'm going to go up 1, 2, 3, 4, 5, and then to the right, +4, 1, 2, 3, 4. And then notice that since this equation has a positive slope, I see that my line is going upward when I read it from left to right. Now, we are asked about the relationship of these 2 lines. Parallel would mean they run side by side and never touch. In other words, they have the same rise over run or the same slope. Now, clearly they don't run side by side, and you can see that their slopes are not exactly the same. I have -4/5 and +5/4. The other option besides neither is perpendicular. Perpendicular would mean that the two lines cross at a perfect 90-degree angle. Another way of saying this is that their slopes are opposite in every way. Whereas the first line has a slope of negative 4 as the rise over 5 as the run. Notice that if I took this and changed it to a positive and then flipped it upside down, I would have +5/4, which is the slope of the second line. So these two lines have opposite reciprocal slopes, which makes these two lines perpendicular. All right, and then the other question that we needed to do that was missed before, let me go find that. Oh, I think I put it in here. Nope, I didn't. Let me pause. All right, and here is the third question from GLA-02, number 14. Find the equation of the line perpendicular to x equals 3 through the point -5, -1. All right, so first of all, let's just determine what we're looking at here when we see x equals 3. That is the equation of a line, but it's not in y equals mx plus b form. All we see is that x is equal to 3, so it doesn't on first glance appear to represent a line. But it is a line because saying that x is 3 and not saying anything else about y means that no matter what y value you pick, your x value in that ordered pair would always be 3. So if we just start plotting a few of those points, let's say we do 3, comma, pick something for y, anything. Let's pick 0. Why not? Um, how about 3 comma 1 for the y value to be +1, or 3 comma -4? It really doesn't matter which y value I pick, the x value is always 3. So really all that we need to say is that x equals 3, because notice that as we start plotting these points 3 comma 0, 3 comma 1, 3 comma -4, it's starting to form a vertical line. Okay, so this, if I did every single y value I could think of, and I could never think of all of them because it's infinite. I mean, even things like 3 comma 0.0003, for instance. Um, every possible line that has an x, or excuse me, every possible point that has an x value of 3 would be on this line. So that is the line x equals 3. Now, we were told to find the equation of the line that's perpendicular, so it's at a perfect 90-degree angle with a perfectly reciprocal opposite slope through the point -5, -1. Okay, so let's at least start by getting this point down. -5 for x, 1, 2, 3, 4, 5. Here's -5, so we're going to have a point at -5 for x and -1 right here for y. So here's the point -5, -1, and we want to use that point and any other point to create a line that would be exactly perpendicular to my vertical line here. Now, just like you see the x and the y are perfectly perpendicular with a perfect 90-degree angle between the two axes, it makes a perfect square. Any vertical line and any horizontal line would be perpendicular to each other. So I just need to go through this point and then make a horizontal line that stays, on that horizontal position. So, or I should really say at that vertical position. So what's common about all the points anywhere on this line? You could try plotting a few of them. For instance, like right here, that would be -3 for x, And what is it for y? Negative 1, right? And then if I maybe go right here, that would be positive 1 for x. And what would it be for y? Again, it would be negative 1. So everywhere I go, no matter where I go, 1, 2, 3, 4, 5 here, let's go to 5 on the x-axis. And what would y be? Yep, you guessed it, negative 1. So the important thing to say when stating the equation of this line is simply that y is equal to negative 1. Now, in the first attempt at doing this question in the other video, I followed it with a similar question that had y equals a constant as the given line. And so it was a little different. So if you haven't seen that video, go back and watch the one that was similar to this. It was the same question, but a different version of the question. All right, so I hope that was all helpful, and I'll see you in the next recording.